So let's do a little math review before we do some type of example. All right. So, okay. Okay, math review. So the reason why I'm doing this is because remember we have these new equations that will be VB plus we have here a new term, which is relative plus A cos whatever S of A with respect to B. Okay, and for the same thing for the acceleration, we have here which is minus omega square AB, S of A with respect to B. And the last one is what? 2 times, is it 2 times omega cos F of A? Yes. Is that what it is? Okay. So what I'm doing the little math review is mostly for this term and this term. And if you remember initially the figure that I kind of did, so let's say we do acceleration of A with respect to B. Okay, so that is our point A and B. And if you remember, I did another figure this way, but that's not going to matter now, okay? I did this type of figure. Okay. What did we say that you will have some type of this relative term? Is when the distance between those 2 points will not be fixed. Agree? So, for example, if you calculate the velocity of A from point C, will you have the relative term? No, because the distance between A and C is fixed, no? Okay, so you calculate the velocity of A from point C, you can eliminate these 2 terms, and you can also eliminate this one, no? Everything that is relative. A, these 3 terms could be, okay? But when you need to keep them, there is something unique about these terms. About this term, let's just think about the velocity. So the velocity, here we are representing the velocity by a mathematical tool which is called vector. And maybe you remember the movie Despicable Me, the one that is called vector. What do it says about itself? And magnitude. Okay, it has correct magnitude and direction. Okay, so for example, so you have 2 unknowns. So in this case, so let's say a vector V. We have magnitude and direction. Correct? So you run over here. V is vector, V bar is vector, V with nothing is the magnitude, with no bar is magnitude, and E hat is what? The direction. Okay, so in this case, or in almost every case, do you know the direction of A with respect to B? Yes, because the direction needs to be along the bar, no? Correct? Okay, so the only unknown that will be over here will be the magnitude. So for example, here I make it straight, but let's say the bar is this way. Generally, this will give you how many unknowns? 2 unknowns, the x component and the y component, no? But if you rewrite it on this form, if you know the directions, how many unknowns will you have? Just 1, because you will know the E, but you will know the 2 E's, no, the direction, but you will be missing the magnitude. Correct? So that is what's going to happen in many, many problems. You need to recognize that a vector has direction and magnitude. So now the next question is how to determine the direction. And you know how to do this, okay? I know that you know how to do it. What happens is that you don't practice, so you forget. So now, just as talking about velocity, I'm going to talk about a general vector. General vector u equal to magnitude u times e. Okay? If you want to find the direction, what do you need to do? Correct? All right, I mean, I know you have done this. It's not that complicated. Let's say on a problem that you have, let's say this bar over here, okay? Let's say we have this. So let's say it will be what? X of A, this will be y sub A, no? Okay, so in a vector form, what is the position of A? What is A? Sorry, where is point A? Where is point A located? X, A, Y, A, no? So this will be the A bar. Now what would be, so you can put the bar, leave the bar. What would be the magnitude? Correct? So what would be the direction vector? If you have A bar equal to what? A times E, we have the direction vector will be equal to A bar divided by A, so it will be equal to what? You can put here the coordinates, no? X and Y A divided by yes? Okay. I'm sure you do all this stuff, no? Okay, see, I'm not planning doing anything new. So let's see if we find now a problem. So let me just pause for a second. So let me just restart the recording and say, guys, about this figure here, I'll show you the solution of the recording. Yes. Okay, so since I know we're not gonna have time to finish it, what about we're gonna do like a discussion for like 20 minutes, all right, to see what will happen over for different problems. Okay, so let's look at problem 17-133, and let's discuss it. So that would be too much. Okay, good. All right, so block A slides up the inclined surface at a constant velocity of 2 feet per second. Determine the angular acceleration of bar AC and the acceleration of point C. So let's just leave it at the angular acceleration of bar AC. Okay? So do the figure, guys. I want you to do the figure, and we're going to do it together, but I'm not going to write anything down. You're going to be the one writing everything. And let's decide in something right now. Let's put other measurements. You want to put them in inches or feet? Inches? Okay, so 4.6 inches, then that will be what? 48. 54, yeah. So put everything in inches. Is that okay? If you put it in feet, it will be what? 4.5, 2.5, 2.5. It gives us velocity in feet, though. So leave everything in feet, yes. Leave everything in feet, but keep it in feet, please. Keep it, so 4.6 inches would be what? 4.5, no? 2.6 inches would be 2.5 feet, no? Yep. Okay, so let's keep feet since they give us the velocity in feet per second. I will give you your hints over here. I will write down small thing on the problem, but I want you to do it on your own. as you do the figure, start thinking about it, okay? Which one is the point between A and B constant?
A and B
is not constant because B is like a color, no? That the bar can slide into, no? Then what do we know about VA or AB? We don't know the magnitude, but do we know the direction? It's going to be on the slope, no? Yeah? Okay. So do the figure. I'll give you 2 more minutes. So block A slides up the inclined surface at a constant velocity of 2 feet per second. So what does that mean? So we know acceleration of A is 2 feet per second, but acceleration of A, the velocity of A is 2 feet per second, but the acceleration of A would be what? 0. 0, no? Because it's constant, so you can write it down on your figure. Determine the angular acceleration of bar AC. The rest, forget about it, okay? So, in this problem, in order to find the velocities, the general strategy is what? Try to find the velocity of one point from 2 different locations. Okay? So, in this case, do we know VA? We know the magnitude, and we know the direction. Everything is known about VA, no? Yeah? Okay, so let me... And then we can calculate also the velocity of point A from where? From point B, no? Okay, so let's do one thing first. So the angle here is 20, all right? So let's first do VA. So we have this. We have our block. We know this is VA. What is the angle over here? 20, no? So it should be another way to do if you want the direction vectors. We have VA will be equal to the magnitude VA times the direction vector, no? You want, let's call it E of A. So the magnitude is what? 2 feet per second. What will be the direction?
to sine, well, actually, just sine 20, that's not fine.
So will be, so what would be the x? Cosine or sine? Okay, cos 20, sine 20. So you can leave this that way, but if you do this, I mean, you can leave it. But what do they tell us? It's going up, no? So really the x should be what? Negative, no? Okay, so, and maybe now you can give me the values. What should be those values?
X is negative 1.88.
Negative 1.88, okay.
Y 0.68.
Okay, 0.6. I'm not that picky about the values. And this will be your equation 1. Next, from the figure, we can calculate the velocity of A from where? We say point B, no? Okay, we kind of discussed that before. Is the distance between B and C going to be constant? No, because this is going to be moving. This is sliding inside this color, no? Correct? So as this block is moving up, the distance between A and B is going to increase, no? So what's important is that it's not going to be constant. Do you see that? So if it's not going to be constant, what does that mean? That we need to add this extra term over here, which is A of A, velocity of A with respect to B, plus the omega of what? How do you want to call it? Will be the omega of what? Okay, of the bar AB or AC, whatever you want to call it, AB, cross S of A with respect to B. In this case, we're going to have a little bit more. Yes.
For the purposes of this problem, do we choose to work in feet or in inches?
We say in feet.
In feet, okay. I thought we chose inches.
In feet. Because of the velocity, okay?
Yep.
Okay, so from this figure, what is VB? VB is 0, okay? So we know we can rewrite now. We know we can rewrite VAB as what?
The magnitude.
Magnitude times direction plus omega AB cross of S of A with respect to B. Where EAB will be equal to what? So remember, we said it should be equal to the vector SAB divided by magnitude, no? Just what we did before. So it doesn't matter which way you do it here, the math will give you the sign, but what would be this vector over here? 4.5, 2.5, no? Yes? Okay, or you could go from here to here, it doesn't matter. But so let's say it would be 4.5 on the X. 2.5 on the Y. Now we need to divide by what? By the magnitude. So if somebody is so kind to give me these values. Did you understand what I just did? Everyone? Yes? Okay.
X is 0.87.
So 8667, I'm guessing, no?
Well, just 0.87.
Okay, doesn't matter.
874.
Okay, 8.874, doesn't matter. And the one will be 0.48.
0.48.
Okay. All right, so what does that mean now? That we can rewrite here VA as being equal to what? Unknown magnitude times known direction plus this one, which is what? 0, 0 omega AB, which is unknown. And what is the position of A with respect to B? Position of A with respect to B?
Negative 4.5. Negative
2.5. So negative 4.5, negative 2.5, and 0. So basically, if we do this calculation, we get the A will be equal to what? Will be equal to 0.874 velocity of A with respect to B plus 2.5 omega AB. On the X, the Y will be 0.48 velocity of A with respect to B minus 4.5 omega AB. So what do we do next? Now we can equate the two, because what? The two unknowns, we only have two unknowns, that will be the magnitude of A with respect to B and the angular velocity. So let's say equate one and two, and this will give you what? 0.874 velocity of A with respect to B plus 2.5 omega AB equal to negative 1.88 and 0.48 velocity of A with respect to B minus 4.5 omega AB equal to 0.48. Did I do which one? 0.48 minus 4.5, 0.48. Oh, yeah, I was looking at this one. Sorry. I look at this one. Sorry. So 0.68. Thank you. Yeah, I don't know why I was looking at this one. 0.68. So you know how to solve this, no? Yeah. So if you get the values, I mean, values are not that important to me, but we can look at it. What's the problem number here? 7133. I don't care that much about the values. That way we can double check. But it might not be. They might be working on different units. We find out now. So what do we use over here? Units? No, I use the same one. So that would be good. So it looks like omega AC is going to be negative 0.293 that we call AB. .293, and the one is 1.311. But we need to be careful here because I'm guessing that if we solve the prime, it should give us negative value. Let's see. Let me check. No, it's the same thing, no? They also took negative and positive. So we should get exactly the same thing as they got. We use exactly the same thing. Here, what's important, because it helps you. I know it's just more work and consuming, but once you get here, write it right away. Oops, more papers. Let's write on the back of this one. That means, yeah, I want you to do now. What is this? This is the speed. Yeah, but it's the magnitude. So the vector will be equal to what? 1.311 times what? So really the vector is what over here? .311 times 0.874. Okay. Okay, 0.6. Okay. I mean, if both were did we take both positive here or? Yep. So which one is negative here? This one should be negative? I mean, if we look at this equation here, this is positive. No, we go from A to B. What I'm saying is that that's what I'm saying. I think this value is negative here. Because we didn't solve it. Did anyone solve this? My impression is that this one should be negative. But the magnitude, not the vectors. Okay, what I'm trying to say is this. All right, is that all right? What I'm trying to say is that when we took the direction, we went from A to B. So it was 4.5 and 2.5. Okay? If you were going from B to A, what would have happened? It would be negative 4.5, negative 2.5. So if we take this one positive, it looks to me like this will be moving to the left, no? The velocity. So when you solve, you should get a magnitude negative 1.311. If you were using the negative of the other ones, then your magnitude would be positive. So it depends on which direction vector you select. Do you know what I'm saying over here? So I don't know. That's probably maybe why it's better not to look at solutions and solve our own solutions, no? Yes.
Between the unit vector of A and the unit vector of AB.
The unit vector where?
There's the
This one here. This is the unit vector.
that unit vector and then the one at the very top of the page. Associated to the velocity.
This is not a unit vector. This is the velocity of A.
The one above that, like this.
Oh, what is the? Okay, so this is E of A. This term, all this term here is E of A. So the difference is that this one here, the E of A, gives you the direction along the slope over here. So negative cosine 20, no? If you go up, sine 20. And this one over here, EAB, is the direction of this bar in which is sliding inside the sleeve over here. Does that answer your question? Okay, so again, my guess is that we cover the solution, but that this one here should be a negative.
Yeah, the X should be negative.
Okay, this should be negative, no?
Yeah.
Both of them should be negative, no?
Well, the unit direction vector is negative 1.88.
But I mean, if we take this here now, wait,
But that, yes, that's the good one.
so then both of them would be negative. These two would be negative. Yeah, this is magnitude.
Then, no, the velocity.
This one here,
Yeah.
this is magnitude.
So how can magnitude be negative?
Because magnitude can be negative. You put the. That's what I'm saying is that when you solve. Okay.
We're not taking the absolute value.
Oh, no, what I'm saying is the other question. Okay. We know the direction. Direction is along the bar AB. So what happened now? If you go from A to B, this is going to tell you that this is moving up. Correct? But if we go from B to A, we are assuming that this is sliding down. Correct? But we don't know if it's going up or down. The math will give us the right sign. Correct? So yes, you can have a negative value
So
if you assume the wrong direction. Was that your question?
well, I was gonna say that when you position A dot B, it should be negative 4.5, negative 2.
That's what I'm saying. If you do that, then I guess you're gonna get positive 1.311.
Yeah.
But if we take A to B in this direction, then we're gonna get negative 1.311. That's what we have been discussing. So you can take either one. Do you understand what we are discussing or not? You, do you understand it or not? Since you asked the question. Because it doesn't matter. It's, you know this direction. You know it's in this direction. You don't know if it's A or B. Does it matter if you take A to B or B to A to know the direction? Both of them are along the bar, no? Okay. If you assume the wrong one, just like we did, we went from A to B instead of B to A, what's going to happen? The math, instead of giving us a positive value, is going to tell us, you know what? This actually goes on the opposite direction. Fair enough? So here, that's what I'm saying here. If we solve this, probably we'll get a negative 1.311 instead of positive. Okay? If you take the one you mentioned, probably you're going to get over here 1.311. If you take negative on both of these values. So again, you have here negative, negative. And now, basically, we need to repeat the process for the accelerations. But this time might be a little bit easier. Because what is the acceleration of point A? Is 0, so that's pretty good, no? Equation 3, right away, 0. Now, what will be the acceleration of A from point B? Do we have the relative term? If you have it on the velocities, you're going to have it on the acceleration. So we have acceleration of A will be equal to what? Acceleration of B plus acceleration of A with respect to B plus what is this term? This term represents what? Which one of the accelerations? I asked you that the same thing last time. What is this? This is a tangential. What is this one over here? The normal. And then this one over here would be what? What is omega or V? Whatever. I think it's omega, no?
Yeah, 2 omega.
Okay, what is the acceleration of B? 0, no? It's spin. Now, what do we know about the acceleration of AB? But this time we know it should be the same as the velocity, no? Yes? Okay, so we have on the velocity 0.874, 0.48 plus IJK over here, 0 alpha AB. I'm going to be fast because almost time. What is the position of A with respect to B?
Negative 4.5, negative 2.5.
Negative 4.5, negative 2.50, minus omega B, we just saw for this, so it's negative 0.293. Yes, square, but I also need to look at the figure a little bit. So this will be this will be negative 4.5, negative 2.5, plus, now pay attention, the best way to do these calculations, so I don't forget it, at least for me, is to put over here 2 times omega AB, which is 2 times 0.293. No, yes, no, this is correct. No, it's not correct. You see, I did a mistake. I always do. No, it's because I did a bigger mistake than that. What is this term? This is the classic mistake. You see, I have done it, so maybe it's a good thing. You come over here. What should be this term? Is this one over here, no? So here you're gonna have 0, 0. Oh, that was correct. 2 times minus 0.293. So I was lucky, okay? Now is where I do the mistake. This should be the velocity vector, no? So you should have what? Negative 1.5, negative 0.3, and 0. Correct? 1 second. And now, all these equations, you equate 3 and 4. Basically, 3 is 0, no? And what would be your 2 unknowns? Correct. So 1, 2, 3, and this one here, I should be able to solve for alpha AB and relative acceleration of A with respect to B with the magnitudes. What's your question?
Boston vector be 1.14 because 1.3 times 0.8 should get a higher number.
I don't know how much is 1.311 times 0.874.
Yeah, it's 1.1.
Okay. On 1.14?
Yeah.
Okay, so this is 1.14 then. And this should be 1.14. But do you understand the procedure?
Yes.
Nothing has changed, no?